All right, check, 1, 2. Everyone can hear me? Those lights are very bright, much brighter than I expected. It makes it easier. I can't see any of you. I'm going to assume you're all having a great time. My name is Evan. I am the Chief Product Officer of Aerospike. Aerospike is a cloud-agnostic, multi-model data platform that is used in many of the world's most data-intensive applications. Trusted by companies like Rakuten, companies like Snap, companies like Flipkart, who recently announced they're using their Aerospike data platform at 100 million transactions a second. So very, very high-performance data-intensive systems. And our goal is to build a data platform that allows more developers to solve more problems, more business problems using more data. So how do we set out to do that? We set out to do that by building a platform that is incredibly delightful to build on and delightful to operate on, that predictably delivers sub-millisecond latency at very high throughputs, both read and write, and that very importantly, especially now maybe more important than ever, achieves market-leading use of compute and storage resources. And those requirements all come into play in a lot of different use cases, but one of the use cases where they become very, very, very important is something that we call real-time decision-making, or specifically AI-powered real-time decision-making at scale. And today I'm going to invite up some of our customers who are on world-class engineering teams that have really figured out these problems. I'm going to start by talking a little bit about real-time decision-making, talking a little bit about what it means, the types of companies that are doing it, how Aerospike is useful. Then I'm going to invite up Tony Du, who is Senior Director of Engineering at Dataminr. And I have to tell you that of all the stuff you see this week, Tony's story is the coolest you will see. It is so awesome. Like the stuff they are doing, turning vast amounts of real-world data into real-time alerts is just super awesome. I am not just telling you that so that no one leaves during my part of the session. I swear to you, it is going to be amazing. After that, I'm going to invite up Victor. Victor is R&D Group Leader at AppsFlyer. I think everyone knows AppsFlyer at this point. This is one of the fastest growing companies in recent history. He's going to talk a little bit about how they have achieved world domination, really scaled incredibly quickly and to just sort of remarkable levels of scale, in part powered by Aerospike. So with that, before we begin talking about real-time decision-making, I just want to set your context with a decision-making framework that we're all relatively familiar with, and that is the human decision-making context. So humans make about 35,000 decisions a day. About 227 of those alone are decisions about what to eat. Unless, of course, you are my girlfriend, in which case that number is 0, which means that I then am making something like 454 decisions a day about what to eat. I don't check that math. But as we'll see, these numbers are extremely modest. I think we all understand that machines are just fundamentally more capable than us at certain things. But I actually think it's interesting to double click on this one and just recognize how much better machines are at this particular thing. So about the fastest activity that occurs in our neurological system anywhere happens at about 20 milliseconds. And to call that a decision would be generous, but it is really a decision. By contrast, some of the customers that we're going to talk about here today, in a 20 millisecond window, they're pulling hundreds of records out of a data store. They are feeding those through multiple neural networks, consolidating the results of those neural networks, and making real business decisions. I'm talking here about like relatively straightforward machine learning models, things like logistic regression, random forest, and so on. I'm specifically not talking about more deep learning large models, although we will get into that and how that kind of fits in. And yet, despite this reality, the history of the human sort of software relationship is really one where humans have been making decisions and continue to make all of the decisions. We've been making decisions in a computer-aided manner. So for 50 years or 60 years plus, we had rules-based software, right? We weren't really able to trust machines to make decisions, but they were giving us information. We were building decision support systems and so on. and we were enabled with this notion of like accelerated human decision making. Then in the last 15 or 20 years, we had this period of machine learning and just massive advancements in machine learning. And this is where I'm talking about we're starting to get like emergent decision making, not entirely deterministic decision making coming from our machines, from our software that we're building. But we're still limited here by humans in a sense. In particular, we're limited by humans. These models that we've been using the last 15, 20 years are very label intensive. There's a lot of data preparation that goes into them. There's a lot of human reflection that goes into the outcomes of these decisions. But still a massive, massive leap forward. And what we see now is really the use of deeper models with advanced reasoning capabilities, the types of models that probably come to mind when we talk about AI, things like LLMs, that are augmenting the high performance of this existing generation of machine learning models. And we're going to talk a little bit more about that later. But in theory, we're entering a phase here where we can achieve human quality decisions or post-human quality decisions without sacrificing the type of kind of unbelievable speed and performance that we saw in the machine learning era in the middle column here. And the result overall is just this increasingly emergent, fully automated, autonomously improving decision making. So to give you some context on scale, because this is, we just talked about humans making 35,000 decisions a day. A customer of ours, a company like Myntra, Indian company, e-commerce space, is making around 500,000 decisions a second as to product recommendations. And they're doing that based on streams of real-time data as well as streams of historic data. I like the Adobe example. I like the fact that there's 10 petabytes of data to draw from for this decision-making system, and that they're able to do it reliably with P95s of 2 milliseconds. But the example I'll dwell on a little bit today or use throughout this introduction is PayPal. And the reason for that is, I think as a consumer, it's the easiest one to relate to. So PayPal has these very advanced inference pipelines that they're using for transactional fraud detection. And this number is probably significantly larger now, but somewhere around the order of 10 billion decisions a day. And that maps out to about 115,000 decisions a second. And so you can see that at this type of scale, milliseconds really, really start to matter. This is where it gets interesting. So when we talk about real time, like what do we mean? Real time, this word gets thrown around quite a lot. And sometimes it means fast, and other times it means really, really fast. And what we mean by real time is a more technically accurate definition, I believe, which is operating within some fixed window that is known. You could say that a non-real-time system becomes less useful as it gets slower. A real-time system becomes useless once it goes past a certain window. So if you are in a decision-making platform that is doing, just to carry on the example, transactional fraud detection, you must finish that analysis within a certain number of milliseconds, because otherwise the parent system that you belong to is going to return a result to the user anyway. And so let's just say that in our system here we have 100 milliseconds in which to operate. So this could again be a product recommendation we need to come up with because the page is loading and such and such. Now, in reality we have less than 100 milliseconds, right? Because there's all this other stuff that's going on next to us. There's services that are rendering pages and pulling all kinds of other data and so on. And so realistically, we may end up with 10, 20, 30, 40 milliseconds in which to make a pretty complicated, reasoned decision. And there are ways to do this. There are ways to optimize. So in the first example that I show up there, the model sequencing, what we're essentially saying is I want to line up my machine learning models in such a way where I'm actually optimizing, maybe it's not obvious, but I'm optimizing here for compute over time. I'm willing to say, go through this model first, and then based on the result, let's go down this pathway or this pathway, which in theory could take longer. In theory, it could be shorter, but we're optimizing for our overall CPU or GPU inference capacity. I also have the ability to say, you know what, I'm going to go with this ensemble approach on the right and say, I'm going to put this data through all these three models at once, even if the outcome or the output of one of these models ends up being throwaway based on the result that I get from one or other of the other two, because I care so much about knowing that this thing finishes in a very, very specific time frame. And we see this in fraud detection, as I mentioned. You see this in recommendations. You see this in ad serving. You also see this in manufacturing, supply chain. There are a lot of use cases where you really do need to finish making a decision in a real-time window, not just a fast window, if you will. So where does the data come from? Where is the data that's coming into these decisioning models? The pattern here is that there's three types of data. There is historical data, which tends to be batch processed. I mentioned earlier Adobe had some number of tens or more petabytes of data that they can pull from during their decision-making process. So this is lots of historic data. Then you have near real-time data, which is sometimes referred to as sliding window data, and can be extremely important in some of these decision-making contexts. You could imagine, for example, if you're looking at transactional fraud, that knowing that someone changed their address the day before or requested a replacement card the day before is probably a much more important piece of information than where they lived 10 houses ago. And then you have real-time data. Real-time data is often the thing that is actually triggering this whole thing to start with. It could be a user's IP address, browsing session. It could be the transaction that they're actually trying to complete. But basically, you have these three velocities of data that are flowing through these real-time decision-making systems. And as it turns out, we engineered Aerospike to solve for all of these. The fundamental reason for that is that with Aerospike, you're able to choose on a workload by workload basis what your storage strategy is going to be. Are you going to put all of this information in flash and SSD? Are you going to put all this information in memory? Or are you going to leverage our hybrid memory architecture and keep your indexes in memory, put your data on flash, and so on? And this is true to the point where we see people building things with, outside of the decision-making use case, we see people building things with Aerospike that are as diverse as web caches on the real-time side to sort of financial systems of record on the historic side. And that's just really a function of this flexible data storage and retrieval architecture. We have added real-time primitives or primitives that really help with decision-making, like our Aerospike graph database. This will allow you, based on one piece of information that you have about a transaction or a device or a user, to very quickly ingest as much information within the neighborhood of that user in order to use in these real-time decision-making contexts as well. It's fast. Did I mention it's fast? You need that speed if you're going to be doing decisions in single-digit, double-digit milliseconds, huge amounts of throughput, and database-like features. So things like cross-regional strong consistency. What this means is that we're not asking you to implement a secondary data storage layer to power your decision-making engine from. You can just go directly from your system of record, your one data platform that you're using, and that we can handle enough throughput that you're not actually going to interrupt your other day-to-day interactions with your data. Okay, so we're back here. And what I've been talking about mostly so far is this middle column. So middle column, ensembles or orchestrations of very low latency, potentially relatively shallow, high performance machine learning models combined to enable high performance real-time decision making. But for most people in the world, almost exactly 2 years ago, our definition or our expectations of AI changed, right? ChatGPT just came running through the wall like the Kool-Aid man, and it was like all of a sudden we're like, okay, what do we do with this thing? And I think even for people who were close to data, like data practitioners, the question started to become, well, where does this fit in? And so I want to talk a little bit about how we go from those types of transactional high-performance decision-making systems powered by classical ML to something that I'm referring to here as autonomous decision improvement. And some of this is aspirational, I will admit. This is not something where I could point at any specific company and say, hey, they're really like doing all of this stuff and they've got it totally ironed out. But what we do see is we see customers doing individual pieces of this. And Tony's going to talk a little bit about some of the ways that they combine faster, less expensive models with deeper, richer, more expressive models. And yeah, we start to see these things all over the place. So generative AI or LLMs or deep learning models or however you want to think about it, foundation models, they're awesome. I mean, it's like the coolest thing we've all ever seen, right? But they are expensive. The reality is they are expensive and they are slow. And I'm not going to be the guy who's up on stage on being recorded on video at a conference bidding against software getting cheaper or faster. It will get cheaper and it will get faster, obviously, but we're starting from a base of kind of like 3 to 5 orders of magnitude difference compared to these lower latency machine learning models. And what I found in personal experience working with generative AI is like from an API perspective or running things on local infrastructure is where they tend to get really expensive is when you break out of like human-bounded systems. You break out of human-bounded interactions. So, a system like a coding copilot or a customer support system is sort of fundamentally bounded in terms of its throughput by the fact that it's interacting with humans. When you really just plug these things into like machines and go bananas on them, it can get like very expensive very, very quickly. And so what we've started to see is companies out there looking and say, okay, well, what are the things that each of these like class of model has over one another? And I've already talked a lot about fast inference and scale economics and the interpretability of these smaller models. But of course, generative AI brings all these other capabilities, the ability to look at unstructured data, the ability to do zero-shot generalization. Just like there are things that these models will do that we will never be able to do any other way. Even to go as far as to say, using large models for example, for embeddings, and then using those embeddings during real-time transactions later. So we get to this kind of model, which is the best of both worlds, if you will, where what we see is folks continuing to apply these very fast models, let's say like within the real-time window, right? So I have 100 milliseconds, I have 30 milliseconds, I have whatever I have. Within that window, I'm going to use these smaller, lighter, faster models. But on either side of that, like before that window starts or after that window ends, I have the ability to use these much more powerful models for things that they are very good at, things like grading the fast models, things like automated feature extraction, or there's a notion of context-aware automated feature extraction, actually using large models to write the Python code and deploy it in production that will do more effective feature extraction for our faster models. Helping to interpret results, communicating with customers as to like explaining the results of the decisions that were made in these real-time decision-making systems. And that brings us to a vision of the future. Now, you've probably heard a lot already today and will continue to hear a gigantic amount for the continuation of the week, I am sure, about agents and agentic architectures. And I think there's probably a reason for that, which I think it's probably the most exciting paradigm in software today. It is just a super compelling way to go and think about building systems that combine models and are able to talk to external systems and are able to reflect on their learning and iterate. It's just it's an incredible thing. But what we see happening here is really companies owning these high-performance models that are used in these real-time decision-making systems, also owning and shepherding these agents or this agentic style of software that actually can go out and figure out what to learn and what to encode back into these high-performance models. So imagine if your real-time decision-making system was capable of going through your CRM, going through your support system, and learning about how to tweak these automated decisions that are being made, and then actually feed that back into either the training or the evaluation of those models. And of course, and most importantly, Aerospike at the bottom there is storing all of your structured, your unstructured data at those 3 velocities that we talked about earlier for decision-making systems: the historic data, the near real-time data, and the real-time data that make all of this possible, or will make all of this possible, I should say. So with that, I want to invite up Tony, and Tony is going to tell you about some of the incredible stuff that they're doing over at Dataminr. Thank you, Tony.
Thank you, Evan. Well, good afternoon, everyone, while the light is really bright. I hope you have a great first day as a conference so far, and thank you for joining our sessions. My name is Tony Du. I'm a Senior Director of Engineering at Dataminr, and today I'm excited to share with you about Dataminr's story and how we solve some of the toughest challenges, identify critical needle in the haystack events, identify and enable our customer to be more proactive and effective in responding to incidences. So let's imagine you are part of a corporate security and crisis response team, and there's an active incident nearby that might pose a risk to your employee and asset safety. How quickly would you like to learn about it? From the news in 8 hours, a few hours, or even an hour? Well, all of these options are probably too late, or later than what you would like. You would probably want to know about right away, as soon as possible. And that is where Dataminr comes in. So what is Dataminr? We are an AI platform that provides real-time alerts on events, risk, and threats to our user, enable them to stay informed, act quickly, and respond effectively. Let's take a look at a couple examples of our alerts in actions. On September 24, Dataminr alert a supermarket about a chemical leak nearby, prompting them to evacuate their employee and customer for their safety. As the situation unfolded and the evacuation order lifted, our Regen AI solutions provide the much-needed situations awareness for them to quickly and safely resume operations. In another example, in early October this year, the Chicago Department of Aviation received an alert from Dataminr about a denial of service attack targeting Wayne County, Michigan Airport Authority. This early warning gave them much-needed lead time for them to fortify their systems and prepare for a possible attack. Well, just 8 minutes after they received Dataminr alert, they faced an attack with over 3 million hits in the span of 11 minutes windows. The attack ultimately subsided because the attacker realized they could not breach or disrupt the systems. Thanks to our alert, they were able to take proactive measures to protect the system against disruptions and maintain operational integrity. Think about the impact and the consequences had the attack been successful in disrupting the aviation system. We are more connected now than ever. Events occur and share around the globe in many different ways. From eyewitnesses, individual on the ground, like you or me, or just some random tourist walking down the Las Vegas Strip, reporting what's happening near them in many different languages. Or a sensor on the ship detecting that is deviating from the original route. Or an airplane transponder in the sky reporting that there's a drop in elevations, or stop transmitting data altogether. Our AI platform processes digital signal from a vast network of publicly available sources in real time, identifying events that are happening on the land, in the air, and at sea. We provide the earliest signal to our customer. For instance, if you might remember and recollect in early March this year, March 26, when a container ship struck the support beam of the Francis Scott Key Bridge in Baltimore, Maryland, caused it to collapse. Dataminr alerted user an hour and 14 minutes before it report on any major news outlet. In another example, on July 19, Dataminr user were informed of the CrowdStrike breach or outage, nearly an hour and 30 minutes before it reached mainstream media. So Dataminr customers are organizations across various sectors worldwide. Dataminr for News provide the very first signal on breaking news and emerging story to journalists in over 1,500 global newsrooms. In the private sector, we deliver real-time alert on physical and cybersecurity threats to companies and organizations that including 2/3 of the Fortune 100, half of Fortune 50 company, including some of the leading AI organizations that you might know of, like Microsoft, Amazon, Google, NVIDIA, just to name a few. We provide real-time insight on emergency, crisis, and threats to government agency, public sector organizations, and first responder. And that's including the Department of Defense, NATO, more than 100 US government agencies, 20 international governments, and the UN in over 100 countries. Every day, Dataminr processes billions of input of multimodal data across multiple platforms worldwide. Our AI platform supports text processing in over 150 languages, image, video, audio stream, as well as machine-generated sensor data from over 1 million sources. And that's including data that's coming from the surface web, deep and dark web, as well as network of sensors. So let's talk a little bit about AI. There are many types of AI. At Dataminr, we mainly focus on predictive AI and generative AI. And for those who are not familiar, predictive AI is a branch of AI that uses historical data and patterns to generate insight and forecast future events and outcomes. It serves as the foundations for real-time decision-making systems. Generative AI, on the other hand, is a type of AI that creates new content based on patterns and examples that are learned from a large data set. Dataminr AI platform leverage predictive AI to analyze data, identifying patterns and correlations across multiple modalities in order to help with event detections. We use generative AI to generate dynamic live update event brief. A regen AI solution not only describes event as it is being unfolded, as well as update summary as new information emerge, allowing users to track events and crises without the need to read through static report. There are a lot of conversations about LLM recent years. The first LLM, or large language models, as we know today, trace back to the evolutions of transformers-based architecture, starting with the transformers models trained with roughly 65 million parameters, introduced in 2017. And since then, the number of parameters used in LLM have seen grow exponentially. At Dataminr, we start using and deploying LLMs in production since 2019. We not only train our own LLM models, but also using open source model, adapt and fine-tune them for our use case, using our proprietary data that's unique to Dataminr. For Dataminr, the ability to process a large amount of data quickly and the ability to handle a continuous stream of publicly available information in a scalable and cost-efficient manner is critical for our success. From billions of input, our AI platform produces hundreds of thousands of alerts daily. And to do that, we employ a range of engineering and AI approach and methodologies. At Dataminr, we believe in using the right AI model trained with the right data for the right task. And so if you look from the left to the right, starting with a very large amount of data, we leverage a mix of smaller AI models. These could be traditional machine learning models, deep learning, that are more cost efficient and optimized to run at scale in order to achieve fast enrichment. Leverage these model output, we then filter and reduce the content into a smaller data stream. Then we apply a larger, more expensive neural network LLM models to perform advanced and complex generations and decision making. So let's start from the beginning. As informations flow into our content acquisition system via a number of low-code and configurable ingest services, we perform normalizations to convert data into our internal format and schema, as well as deduplications. For example, for content type like audio stream, we would use AI to segment, pre-process, and transcribe them into text before sending it downstream. For deduplications, depend on content type and data. Sometimes we would have to dedupe information across days of data. Aerospike fit perfectly here as a use case because it supports low latency, high request throughput for a very large amount of data in a scalable and cost-efficient manner. As data being converted into our internal format, it flows through what we call the enrichment content pipeline that powered by over 50 AI models across multiple types, NLP, computer visions, and others. These AI models provide valuable real-time metadata such as predicted language, geo-informations, name entity recognitions, entity linking, tagging, OCR, logo detection, just to name a few. These enriched metadata is not only valuable for our alert generation process, but also allow us to remove a significant amount of irrelevant content. At Dataminr, many of our AI models are trained for a specific use case on a specific domain type of content, and oftentimes they rely on each other to function properly. And our orchestration system manages these connections seamlessly using technologies such as Aerospike. The database serves as a sink for all of our AI models' output. It also serves as a source where our orchestration system would pull the data from and feed back to other AI models in real time. By the time data reach our alert generations subsystems, the total amount of volume reduced by over 95%. At this step, we further do deduplications, filtering, and alert and content enrichment generations, again using AI models. And oftentimes, these are much more complex and larger models, LLM, neural network, and such. As data, for a couple examples, as data being converted into alert, our system automatically links them together to events that we have alerted on previously, where possible. We also automatically update live event brief summary across all alerts relate to a single event using the Regen AI solutions that Dataminr launched earlier this year. Just to tie everything together, in order to achieve what we're doing today, processing billions of input daily, detecting events that are relevant to our customer in real time, there are three key elements to our success. First, we're relying on our proprietary 12-year label data archive that is unique to Dataminr and cannot be replicated elsewhere. We use that information to train our AI models. We also rely on our internal domain expertise and processes to help with AI model training and evaluations, as well as real-time alert generations process. Last but not least, we rely on strong software architecture and technology in order to support our AI systems in real time. Thank you. And next, I think we have Victor.
Hey. Hello, everybody. Super interesting story from Dataminr, and I'm here today to tell you a bit about AppsFlyer and our scale. So I'll start with a simple question. How many of you, well, basically I don't see, but I'll try. How many of you see mobile ads on a daily basis? Okay, cool. Impossible to avoid, right? How many of you click on those ads? Okay. Download, install, play, purchase through those apps eventually? No one. Well, there are hundreds of billions of such events, impressions, and clicks on a daily basis. And I'm here today to tell you the story. I work at AppsFlyer for the past 6 years. I'm leading the data platform group responsible for the real-time and data analytics platforms. I have vast experience in AWS ecosystem and data processing. And one of the biggest benefits at working at AppsFlyer is that I can do it at scale. So a bit about AppsFlyer. AppsFlyer is the world's leading mobile measurement attribution platform. We have more than 1,500 employees across 9 global offices, and we cover more than 65% of mobile measurement market share. AppsFlyer is helping app owners optimize their advertising campaign and find the right audience for that app. We expose digital analytics and handle massive amount of data each day to make it happen. In high level, we're doing it by collecting engagements such as clicks, impressions, app install, and in-app events. Then we process all the data and get meaningful insights and analytics for our customers, basically which campaigns works the best. So next time you see an ad for a mobile application, download the application and engage with it, knows that AppsFlyer was probably part of that campaign. Now, how does Aerospike fit into our architecture? We use Aerospike as a key value database, which helps us store those ad engagements and read them to make our attribution action. Let's talk about scale. Evan mentioned few customers. Let me show you AppsFlyer scale. On average, we write around 2.5 million objects per second, which translates to around 1 peta of data at any point in time. Our retention varies from hours to days, so we always have a massive amount of writes and deletions. What about reads? We perform over 4.5 million reads per second to those objects. And we must have a very low latency to meet our application requirements. It's around 400 billion reads per day. What do you think is the P99 latency in such deployment, in this particular deployment? It's under 1 millisecond. The P99.9 is under 1 millisecond, which is very impressive for our scale. This meets our application requirements, and we're able to perform our logic, and more important, we give a very good experience for our customer. For the advertising world, every millisecond counts. We have one more requirement which is crucial for our production. We need the ability to scale up and down very frequently and without an impact to the functionality or performance of our application. As our traffic trends are very dynamic and unpredictable, our infrastructure must scale up and down very efficiently. For example, large sports or shopping campaign can increase our traffic dramatically in just a few days. This graph shows how we scale down Aerospike by almost 50% and back up by 100%, and while doing so, we maintain the same performance and SLA as in steady state. Let's talk about how we combine our tech to make our infrastructure with Aerospike extremely cost-effective. We run our infrastructure over Kubernetes using EKS, which means that Aerospike is running as a stateful application. This is usually very difficult to maintain compared to stateless application, right? Microservices. Aerospike developed an open source Kubernetes operator, which we use and help us manage this state. It significantly simplifies the operational overhead, and the open source is very nice because we can see the code, we can contribute, and we can fork if needed. This gives us the option to benchmark for performance and test cost efficiency in a seamless manner. Containerize, we just switch the hardware and see the performance. We run Aerospike over Graviton, and we saw a significant improvement by more than 20% compared to Intel-based instances. So just switch the CPU architecture, and you get much better performance and cost. And we're able to scale up and down very efficiently. Carpenter is doing the heavy lifting for those nodes, so we can provision nodes in under 1 minute and scale them down when they are not needed anymore. And we spread across multiple AZ and use, of course, local storage. And finally, we reduce the operational overhead of the system as we expose our configuration and APIs to our developers, GitHub flows, and infrastructure as code, so they can change their cluster configuration, even the application parameters, with a simple git commit. So we get the value from Aerospike by getting very low latency. We're very intensive in reads and writes, and Aerospike handles it seamlessly. It scales up and down according to our traffic trends, and we're able to use it in a cost-effective way by utilizing Kubernetes and the latest technology stack. This is the final graph I'm going to show you, and I really like it because it sums up the value we are getting from Aerospike. The above purple line is the compute cost of an alternative solution we used before Aerospike, and the blue line represents the Aerospike deployment over Kubernetes. So, as you can see, it took us only 2 weeks to go live to production after we benchmarked and tested the deployment. Of course, migrated the data. And we reduced our compute cost significantly by around 60%. So, we're doing millions of reads in under 1 millisecond, reduce our compute cost by 60%, and we run Aerospike over Kubernetes, which significantly improve our operational overhead and empowered our developers. Thank you.
Thank you, Victor. Is this mic on? Does that sound like it? Quite loud anyway. So I want to say thank you again to Tony from Dataminr and to Victor from AppsFlyer for joining us here at AWS reInvent. In summary, our session today, we really talked about AI decision-making at scale, leveraging the best of fast, inexpensive, efficient machine learning models, combining that with advanced deep learning techniques. We talked about how, and Tony really talked about how data sources here remain completely essential and is not going to go away anytime soon in terms of differentiable value as it comes to AI and machine learning. And Victor really taught us about how scaling shouldn't and really can't be an afterthought for these types of systems, particularly the relationship between scalability and performance, meaning that we need these things really on day one. We are not going to do a recorded Q&A, but the three of us will hang out here for 15 minutes until the end of the session, and we would love to hear from you. So please feel free to come up and have a chat about anything relevant, anything that's on your mind. Can't wait to meet you all. Thank you.